Hello students, so in this video we'll be discussing about the universal law of gravitation. So initially let us try to understand with an example. Suppose there is a stone which is tied to a thread and we are standing in the center and we are turning the stone in a circular path. Now when the stone is moving in a circular path, the stone at any point experiences two types of force. One force which tends to throw the stone away or out of the circle along the tangent, and this force is called the centrifugal force. So when any body moves in a circular path, it always experiences a force which will tend to throw it in the outward direction, and that is the centrifugal force. And to keep that object which is moving in a circular path in this circular path, to maintain or to keep on continuing in this circular path, there has to be a continuous internal force which will help it to remain on its path, and this centrally seeking force is called the centripetal force. So these are the two forces which are acting on a body which is moving in a circular path. That means in order to keep this stone in this path, you have to continuously keep on pulling the stone towards the center. So this kind of force is also experienced by any heavenly object, which is, let's say, the satellites going around the planets or the planets going around the sun. They always experiences a centripetal force, and from here we have this universal law of gravitation. So according to the universal law of gravitation, let us say that there are two bodies having mass m1 and m2 and separated by a distance d. So this distance d is from center to center of both the bodies. So according to this universal law of gravitation, any two objects in this universe, any two objects, it can be two pencils lying across a distance, it can be a desk and a bench, it can be two person, or it can be two heavenly objects. So according to this law, any two objects in the universe, they attract each other with a force, and this force is known as the force of gravity or gravitational force. And the force is, two points are there related with this law. Number one, the force is directly proportional to the product of the masses of the body. That is, from this assumption, F is directly proportional to m1 into m2, and number two, inversely proportional to the square of the distance between the two bodies. So the distance between the two bodies were d, so it is inversely proportional to square of the distance. Now this one was obtained from one of Kepler's law. It was taken by Newton and it was used to derive the equation for universal law of gravitation. So combining these two, what do we end up? Okay, so combining 1 and 2, what do we get? That F is proportional to m1 into m2 divided by d square. Now in order to remove the proportionality sign, what we do, we bring in a constant. So F is equal to capital G m1 m2 divided by d square. Now what is capital G? Capital G is the constant of proportionality called universal gravitational constant. So now we will try to explain what is G, or rather capital G. So from this equation, F is equal to capital G m1 m2 divided by d square. If we shift, we take d square here and we bring m1 m2 below. So we are left with G is equal to fd square divided by m1 m2. So this is the equation or expression for capital G. Now from this expression we can get the SI unit for capital G. So capital G is equal to fd square by m1 m2. So F's SI unit is Newton, force, distance SI unit is meter, so meter square, mass 1, mass 2, so kg into kg, that is kg square. So it is Newton meter square per kg square, or we can also write it as nm square kg to the power minus 2. So this is the SI unit for capital G. So what is the value of capital G? The value of capital G has been found out to be 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now this is a constant value. It is constant throughout the universe. So next we need to define what is G. So G is actually universal gravitational constant. So how can we define it numerically? So from the expression G is equal to Fd square divided by m1 m2, if we take a condition where m1 is equal to m2 is equal to 1 kg, that means both the masses are unit masses and the distance between both the object is 1 meter, that means separated by unit distance. So if you put these values in the expression, you will get G is equal to F into 1 square divided by 1 into 1. So 1 square is 1 and 1 divided by 1 will be 1. So it will become F into 1. So we end up getting G is equal to F. So if someone asks us that what is universal gravitational constant or capital G, we can define that universal gravitational constant or capital G is nothing but the force of gravity between two bodies having unit masses separated by unit distance. So this is the definition for capital G. So here it is written, therefore universal gravitational constant or G can be defined as the force of gravity between two bodies having unit masses separated by unit distance. Now there are different applications of force of gravity around us. So we know that the planets and satellites there revolve in a fixed orbit. They stay in their orbit as they are revolving. They simply don't get lost into the space. So they are revolving around the orbit with the help of this force of gravity. They remain in their position. Then formation of tides. The high tides and low tides occur due to the gravitational pull of the sun. Then all objects remain on the surface of the earth. If you are not floating away into space, you are able to remain on the surface of the earth. It is because of the force of gravity of the earth. Next, occurrence or precipitation of rain and snow. So when rain or snow they precipitate towards the earth, that is due to your force of gravity. Then we have this atmosphere around the earth. So the atmosphere, the air is there around the earth. The air is simply not floating away because of the force of gravity. So all these are the some applications of force of gravity. So there are certain numericals which needs to be done depending on the equation that we got for the force of gravity. So what are two examples I'll be discussing very quickly so that we can understand how to do numericals related with this force of gravity, with how to deal with this expression. So here we have, fine. So the question stands here is, calculate the force of gravity between earth and the sun given that mass of earth is taken as 6 into 10 to the power 24 kg, mass of sun is 2 into 10 to the power 30 kg, and distance between earth and sun is 150 million kilometer. So mass of earth we take as m1, we can take it as me also, e indicating earth, 6 into 10 to the power 24 kg. Mass of sun we can take as m2 or ms also we can take. Variable, it should be according to your convenience, 2 into 10 to the power 30 kg. Distance between earth and sun, it is 150 million. Million means 10 to the power 6. So 150 into 10 to the power 6 kilometer. So what I have done here, actually this 150 I have written in scientific notation 1.5. So I have reduced 2 decimal place here. So here I have increased 2 decimal place. So it becomes 1.5 into 10 to the power 8 kilometer. Now SI unit of distance is meter. We need to convert it into meter. So 1.5 into 10 to the power 8 into 10 to the power 3. That means 1000. We are multiplying with 1000. So we end up getting 1.5 into 10 to the power 11 meter. Value of G is known. Actually value of G is 6.67 into 10 to the power minus 11. But for the purpose of numericals, to make it more convenient, we can round it up and take it as 6.7 into 10 to the power minus 11 Newton meter square per kg square. So this is the formula. So we place the values in the formula. 6.7 into 10 to the power minus 11, that's the value of G. Then m1, mass of earth, 6 into 10 to the power 24. m2, mass of sun, 2 into 10 to the power 30, and it is your distance square. So distance was 1.5 into 10 to the power 11, whole thing square, because the formula is distance square. Now this sum seems to be very complex, but actually these sums are very simple if we know how to simplify them. So all the 10s, 10 to the power minus 11, 10 to the power 24, 10 to the power 30, then this one, all these we take on one side. So we have 10 to the power minus 11 plus 24 plus 30 on top, and below 11 whole thing square is 10 to the power 22, 11 into 2, 22. And all the numbers we put on one side, 6.7 into 6 into 2, and below 1.5 whole thing square, so 1.5 into 1.5. So on this side we are getting 80.4 on top, below 2.25 into this 22. If we take on top, it will become minus 22. So plus was plus 24 and plus 30, so that is 54, and minus 11 and minus 22, so minus minus plus, it becomes minus 33. So if you solve this, it becomes a very simple number, 10 to the power 21, and this you calculate, we end up getting 35.73 into 10 to the power 21. So we can write it in scientific notation. Scientific notation means writing one number in the unit place and putting rest of them in the decimal part. So when I shift this, that means I am reducing one decimal, so here I will increase one, so this will become 10 to the power 22, and this one, it becomes 3.573, but 573, since I have rounded it off, so 7 is more than 5, so I have written it as 3.6 into 10 to the power 22. So we are finding out what force, so it will be Newton. So this is a very simple way of solving sums on gravitation, where on putting the values you might feel that the sums are very complex, but actually they are not. One more example we are going to discuss. So there's another example. So in certain sums we need to use algebra. We have to take the variables, take the values, because direct numerical values may not be given. So for example, like calculate the new force of gravity between two bodies if their masses are doubled and distance between them is half. So what is said, that masses are doubled and the distance will be half. So for this, let us take the original masses to be m1 and m2 and the distance between them as d. So what will be the original force? Let us take the original force F is equal to G m1 m2 divided by d square. You don't have to put any numerical value here. Simply put the variables. Now what is said in the question? So according to question, if masses are doubled and distance is half, so masses are doubled means, so new force F dash, I have taken a new variable, formula will now become G. Masses are doubled, so the first mass will become twice m1, second mass will become twice m2, and the distance is half, so now the distance will become d by 2, but it will be d by 2 whole thing square. Don't put d by 2 d by 2 square, that will be wrong. It is distance square, so distance now is d by 2, so d by 2 whole thing square. So on top 2 into 2 is 4, so we can take the 4 out, so we are left with G m1 m2, and below it is d square. If we break the square here, the bracket, so it will become d square divided by 4. So 4G m1 m2 was there. This one, if we make it multiplication, this will go up, so it will become 4 divided by d square. 4 into 4 is 16. G m1 m2 divided by d square. Now G m1 m2 divided by d square, what is this? This is nothing but the original force. So F dash is equal to 16F. That means new force is 16 times the original force. So this is how also few sums needs to be done in relation to force of gravity. Thank you very much. I hope the concept is clear to you.